Everyone. Just like usual, I'm gonna wait a little, make sure everything's running smoothly. So enjoy some silence for a few seconds. I think we're good. Okay. I'm listening to music while I stream today. There we go. Okay, so today we're gonna do something a little different. We're just gonna go through DeepML questions and try to convert them to Tinygrad. Tinygrad is a pretty great project. It's like TensorFlow, but I mean, it's supposed to be a lot faster. Hold on. There we go. There we go. It's like Tiny. I don't know if I said it was faster. I think they're trying to be faster, and they're also trying to work with any GPU setup. So AMD, they have Tinycorp. Yeah, Tinycorp, where they basically sell tiny boxes, which are pretty intense computers, to say the least. One day, I'm gonna find an excuse to make this a business expense, but until then, it's on the wish list. But they also have this great open source community and project, so I'm going to try and convert some of our questions, because right now we support NumPy, PyTorch. NumPy, we need to add more support for more of our questions, but I'd like to add Tinygrad support as well. This is like, I mean, this isn't great programming practices. I'm pretty sure we have some, yeah. So like question 15 has Tinygrad. I don't think it's, I don't even think the solution runs correctly. I don't think this is a good question. So, and even on our open source repo, we have a few. So you see question 1. We have Tinygrad. And we have a solution, starter code, so on, but I want to go through all of these and just do it from scratch and, I don't know, I guess show how I would go about this and making new questions. Let me make a quick branch, I don't know, Tinygrad questions. Part 1. Okay, so let's take example 1, vector dot product, so we just want to take, input A and input B and basically do dot product. So I have a collab notebook right here that I'm going to test all of these things out on. I mean, okay. I'm trying to think, I think it's called a tensor. I think that's like their list or their array. Oh, interesting. I don't think I need a gradient for this. I don't need it. I wonder what the default is. Is the default? It has the same. I wonder if there's lowercase tensor and uppercase tensor. But we're learning. That's pretty interesting though. It's nice that it gives you. Okay, I might need to learn a little. I mean, I guess this is a learning stream, so might need to look into, I guess, the basics of Tinygrad. Let's see, I think they have some good documentation. So what's currently on there is Tinygrad solution, the matmul, AT. I don't even like how they did AT. I feel like, should I pass it in as a tensor? Probably. I probably should let the user know that it is a tensor. Okay, A is a tensor, B is a tensor, so you shouldn't need to do this. You should theoretically be able to just return okay. Wait, is this solution? Yeah, this is the solution. Change the starter code. Let me see if this works. What are you angry at me about? Oh, that makes sense why you're angry. Theoretically, I do this, A comma B. AT is not defined. It's a good point. Blah blah blah. Out of two list attributes. Oh, we never sent these to tensors, so they should be. Tinygrad. Yes, thank you. I need to learn how to spell better. So let's create these as tensors. Okay. Now if I pass these to this, coolsies. Saying about that soup too. That's what our current test cases look like. Okay. So, matrix dot product of, I mean, just to A and B, but basically converting it to numpy and then to a list, which I guess would be. Okay, and then our system will be able to process a list easily. Like I'm saying, we could check if that's correct or incorrect. Okay, okay. I mean, this question is relatively easy. It's just the dot product between a matrix and a vector. Yes. I really should review all of these and make sure everything is good. In this section, I feel like it's pretty good. Yeah, it says you should return -1 in that case. Let me see what the test cases look like. It's becoming just like a deep ML improvement session. It's good. It's fine. Okay, so let me edit the starter code too to let users know this is a tensor. this is a tensor. What is this? Starter code? Why am I giving people solutions? No. No, I don't want it. No, just tell them what to do. A, B, Tinygrad, input Python lists, NumPy arrays, or Tinygrad tensors. No. Inputs. Be tensors. Turn on 1D dimensional. Yep. Okay. This seems good. Oh, let me fix this. Let me just copy and paste my solution that I just made. My uppercase W. I'm surprised there's not more spelling issues with a lot of these questions. Okay. This seems good. Save. Let me. Might as well add another test case. I feel like 3 is should be the minimum. Just take this one that we were working on because we know the solution and we have the inputs. Oh, I also need to change everything to tensors as inputs. Tensor. Okay. Tensor. Make sure tensor is imported as well. Yes, tensor is imported. Should be a tensor. It should be a tensor as well. And this we need to change to tensor, but I mean, yeah. We'll just grab this. I know, quite riveting, streamy, formatting things nicely. I hope the actual part is slightly more entertaining of me solving questions using Tinygrad. I mean, this was an easy question, so again, entertainment level goes down. Let's see. That does not equal -1. It should be 510. Yeah, 510. 510. Okay. Okay. Let's commit these. Q1. Okay, so question 1, we're good. I'll deal with pushing these changes. I mean, theoretically, I probably should just have it set up where this repository updates the site directly. A little risky here and there, and I need to spend a lot more time making sure that that's a safe way of doing it. But I'll deal with, but the current setup is I deal with the upload after, but it's relatively simple, but I'll do that later. So question 1, we have Tinygraded. Question 2. What's question 2? Should I add a next button to each question? Let me know in the comments or in the chat, because I feel like that might be helpful, at least going through these questions right now in order. I do like the random feature I added. I know it's very simple, but it makes the site a little more enjoyable in my opinion. Because a lot of times I don't know what I want to solve. I just want to solve something. Okay, back to the questions. I don't think you need more than this. I feel like you need a transpose of the matrix. That seems like a good description. This is the transpose. I mean, yeah, no need to overcomplicate stuff. What is the breakdown? Why do I have 5 breakdowns here? What could this be? Determine the number of columns in a matrix. Determine the number of rows in a matrix. I guess this is like everything you might need. Fine. Why is the transpose of matrix A? Transpose of matrix A. Flattened. They mean transpose it and then flatten it? Oh. I'm not even using NumPy. Okay, fine. I also want to add support for just Python. So some of these will like this is a relatively difficult. It's still maybe medium level difficulty if you just have Python. More annoying than anything, but I feel like then you really can't just do. Or not B dot transpose, A dot transpose. Because I'm assuming this should give me the right. Oh wait, it won't. This has no attributes. Yeah, but I could import NumPy. Make this an array. Transpose it. There's 2 lists of functions. To list is a function. So yeah, I could write it like this, and that's a lot easier. Yeah, what we're doing. So that's how to solve it in NumPy. In TensorFlow, I'd imagine I should be able to just do this, but I don't know if transpose is or if .t is a method in Tinygrad. I think A was already a tensor. Maybe I was wrong. Let's see. I already set up as a tensor. What was A originally? A NumPy. I mean, when I print out A, oh, I think it's lazy, so it actually doesn't run the results until. Like if you do .numpy, then it runs it. I could be wrong about that, but that's my current understanding of how Tinygrad works. Because it's just gonna. I mean, no, even if it's lazy, why can't I see A? I could be missing something, to be honest. I don't. It's my first time using Tinygrad. But I wonder why when I just print out A, it doesn't show me what's inside of A. Like, what do I have to do? This to see what's inside A. Small gripe. Okay. Tinygradding. So, question, whatever. Let's see how we did it. So, one thing I'd like, no, I'm not even on it. Tinygrad test cases. I'd rather pass things as tensors. Because I feel like having this is just annoying. I'd rather have my things look nice. a tensor. Oh. We also need to edit the metadata. Oh, I have it set up as easy. I'd agree with that. Starter code, A is a tensor. Cool Z's. Anything else I should do? Inputs. Return or transpose the tensor. Yeah, this makes sense. Sleepy a little. I don't know why I woke up early. Are this shouldn't be needed. Let's see. So this should work. And A was originally, keep on saying this. I don't think I was looking before. One, two, two, four, so it should be 1, 2, 2, 4. Yeah, I should use a better example. Okay. Let's change this to 3. So usually it's 1, 2, 3, 4. Now it's 1, 3, 2, 4. So that makes sense. 1, 3, 2, 4. Yes, this works. So solution is good. Starter code is good. Test cases, we should add one more. Trying to think of a good edge case for. Oh, test cases aren't good. I was trying to think of a good edge case for transposing. Is there ever an instance where you can't transpose something? I guess you could always transpose something, even if it's a single value. So, I mean, it's the same thing. But hey, is there any other languages? I mean, on the roadmap for DeepML, I hope to start offering more languages. I want, more PyTorch questions, more Tinygrad questions. If anyone wants to contribute to the repo, you're more than welcome to. If you have a new language, I'd say just follow, or new library or new language, follow the same structure. So in part 2, you could go just create a new folder called C++ or C or I don't know, Pascal. I don't know what you guys want to use. But I do want to start expanding the libraries we offer. I also just want a basic Python libraries one, so we could call that Python, and that will have no libraries. You just have the basics. I feel like that'll be a fun one. I'd say more fun than practical. I mean, a lot of my things are more fun than more learning tailored than practical. Like most people don't need to own like in the real world you don't just have access to NumPy, but most of my questions you only have NumPy because I feel like that's the best way to learn how things are really going on in the background. Or that or just having straight Python, but I feel like it's difficult, but I don't see why. Yeah, yeah, I should start offering that. It's relatively easy to add to the site. Do I need more test cases for transposing? I don't think so. I feel like I'm fine with this. But I do want to add these as tensors. Change the input to a tensor. So I feel like there's no point of making people convert it to a tensor and then solve it. Tensor is whatever. 1, 2, 3, 4, 1, 3, 2, 4, yeah. 1, 2, 3, 4, 5, 1, 4, 2, 5, yeah. 2, 5, 3, 6, right? 3, 6, yeah. Okay. And let's make sure it's also in the meta. Yes, we have. So yeah, if someone wants to do a different language, also add the difficulty. So if this was just Python, I'd probably put it at medium because it's still relatively easy. But you need to go through the for loops. It's not just .t. So I'm pretty happy with this one. Let's commit this. Say Q2. Okay, we've gone through 2 so far. Let's go into 3. It's also a fun way for me to learn Tinygrad because I really wanted to do this for a while. And I'm sure I could read the documentation and maybe even trying to build a project is always a fun way to learn a new language. That was. Yeah, I feel like building a project is a really good way to learn a new language. It's a lot of fun. I mean, I guess I'm sort of building a project while I create this, but meaning like create a, I don't know, try to find something you're interested in and create a project that has to do with it. Like if you're into horse racing or you're looking for, I remember when I proposed to my wife, I really wish I made it at the end, but I was trying to make a diamond pricer algorithm, which basically, I was thinking of a few different ways of doing it. The most interesting way to me was so they have like zoomed up images of diamonds, and you could sort of see, I'm assuming you could see okay, we'll get into this a little. Was it 5 C's for diamonds? Yeah, carat, cut, color. So I was thinking you could put an image, maybe also put the weight of the diamond, uh, and let the model, because right now it's a very human-based process where someone will inspect it, I'm sure, with like magnifying glasses and a bunch of other stuff. But I was thinking you could have a zoomed up picture, feed that into a model, include the carat, the weight of the diamond. I think all of the clarity, yeah, and just have the model either try and there's a bunch of diamond ranking ratings. GI, whatever. So yeah, there's a bunch of different diamonds. So color scale, clarity, carat weight, cut. I don't even know what that means, but theoretically, I was thinking of 2 different methods. You could either try and have it predict each color, clarity, weight, or whatever, or you could just have it try to predict the price. I think I got pretty far into this, and then I was just like, okay. I don't know why I didn't end up making it. I think Blue Nile. Diamond data. I feel like I had a pretty good data set. I think I was gonna scrape these. So if I click on this, yeah. Yes, I was gonna scrape this. You can see a little blemish, but most diamonds, especially if they're not lab grown, I don't. The whole lab grown, non-lab grown diamond, it doesn't make sense to me. I feel like there's Like, it's the same thing. It's just more expensive. It's made out of the same material. It looks the same. It's just as hard. But one is like, I don't know, a crazy amount more expensive. And why? Because, I don't know, it was found in the earth and people had to spend blood, sweat, and tears just to get it. I don't know. And then also the whole idea of there's a bunch of diamonds and they just restrict the supply of diamonds to make the value of a 1 carat diamond $3,000. Um, but back to the algorithm. I was thinking about taking an image. Maybe you take like this image and you try and the carat weight, and you try to predict the price. And theoretically, you could try and run this through a bunch of different diamonds, and you could find undervalued diamonds or overvalued diamonds. This was a side thing. I was like, oh, maybe I'll get into the diamond business. Maybe I'll try to make this algorithm, sell it. I mean, buy diamonds and sell diamonds. So buy diamonds that, for whatever reason, are a little lower, but it seems like the algorithm thinks they should be higher, and sell them back. But I got lazy, for lack of a better word. I was just like, okay, this is a cool project, and I really wish I did this though. If someone else wants to, go for it. If you do make it open source, I'd love to see it. Oh, I was like, wait, how did I get here? I'm like, project in, yeah, to learn something to build up. I mean, to learn something. A good way to learn something is to build projects. So if you wanted to learn machine learning, building a model that predicts diamond prices might be really good. If you're starting out, I might start with a Kaggle dataset that's already there. Some sort of Kaggle dataset. There's a bunch of them, and just try and build something you find interesting. I still think the interesting, like, don't just choose the Titanic dataset because that's what everyone does. If you find the Titanic interesting and like the history and want to see, who would survive and how many people, like, go for it. Try to make a model there or just do some analytics there. But don't do the iris classification dataset because everyone does the iris classification dataset. There's so many, like, I wish I didn't follow my own advice. I did iris, I did all, all the basic stuff, but there are so many data sets, and you try to find something interesting to you and try to build a model. Then I feel like the question also arises, where does DeepML come in? Like, if you think projects are the best way to learn, which I think it's a really good way to learn, especially in the beginning. I think, let's see. What's the website called? Excalitro. Let's see, how to learn. Add a question mark. How to learn. I feel like there's a few different, at least this is more STEM fields, but I'd say you could do, let me just make a list and see where I go to. I don't want the arrows. Okay. I feel like you could read documentation. And I'll conclude, let's read textbooks, blogs, I just guess reading. So you can try to read through stuff and read blogs and read books, and I guess you could watch stuff, but I feel like all this in my mind is passive learning. And you have reading, so read these, you have watching. Watching is just going to a random YouTube channel and watching it to try and learn. And I feel like passive learning sounds like I'm being mean. Like, it sounds like I'm like, oh, these are stupid ways to learn. Uh, I don't think they're. I think they're good ways to learn. I think, especially, I guess you could also listen, whatever. Um, I don't think they're bad ways to learn. I think it won't stick in your head as much as something else. These are good ways to understand ideas in my mind. Like if you're trying to understand machine learning, maybe or learn machine learning from the first thing, maybe you shouldn't start with a Kaggle competition. Maybe you should understand what machine learning means and understand the core concepts. And understanding the core concepts, either reading or watching a YouTube video, or watching a YouTube video and then reading, are both. Those are all good choices. Um, what was it? Okay, so I would say this passive learning. Well, you just watch something, you just read something, you don't do anything after that. Uh, it's a good way of understanding concepts, but let's say your programming skills aren't really, going to improve much. Your ability to, your true understanding isn't going to go up, but it's like the way I learned in math class. I didn't take so many notes during the class. I usually just try to understand the concept, and then I went home and I did problems. Um, Sometimes it was annoying, especially when teachers didn't follow. Like I usually went over the textbook, went through the sections, and tried to solve the questions. Sometimes teachers don't follow the textbook, and then it's a little annoying for my strategy, but I do prefer listening, trying to understand, okay, this is what we're trying to do, this is how we try to do it, and just trying to understand big picture, and then delving into the actual details and the how to actually do it. When I'm home alone, I feel like that's how you really learn. Like if I took amazing notes, and I mean, notes are nice to have because then you can look back and see how you did it, but if I was like, oh, I understood it in class, or I'm able to solve it while having the answer on the board, I don't actually know anything. So I'm not going to spend all this time taking notes to not understand anything, or to understand minimal stuff. Um, so that's why I listen in class. I learn how to actually do it at home, which I feel like everyone sort of does that. It's just some people take better notes than me. So how to learn passive learning. So let's say that's one. And then you have non-passive learning. Two. Let's say you have interactive learning. Interactive learning is building a project. And yeah, I think just building stuff in my mind. So, I mean, DeepML is relatively similar to interactive. We'll get into where I think DeepML fits into this realm, because I feel like you have interactive learning where you just build projects and that's how you learn from building, and you have passive learning where you read, watch, and yeah. Um, I feel like yeah, I feel like these are the main two forms of learning, and then there's a line that goes between like everything is nothing is zero. Most things aren't 0 or 1. It's usually continuous. Usually things will fall in between here. Um, so I guess now I'd say these are the two ways to learn. And I know some people. So then the question is, okay, so how should I learn? Should I do one or should I do two? You probably should do something in the middle. I mean, I'm thinking out loud with you guys, so these are just my thoughts on it. I say I could be completely wrong. I don't know, because the interactive learning and building a project to learn something, I never did it from the ground up, but it seems really fun. Like you find some project, and you just try and build it. And you don't know something, you look into it. You don't know something, you look into it. I'd say the challenge with that is you're probably going to feel dumb a lot. Like, you're going to feel dumb constantly, and that might discourage you. Be like, halfway through, you're like, I don't understand any of this. And, yeah, I mean, I know that it just feels like, okay, so just power through. But the reality is, even at subconscious level, you might not want to power through if it's constantly a struggle, constantly walking up the hill. Um, but it seems fun, and it seems like a good way to learn. And if you're able to deal with the constant feeling bad, I'd say go for 2. Just start with 2, start building a project. You won't understand a lot of the machine learning concepts, you won't know why things work, but you'll be able to build something and be like, oh, this is cool. And once you get the, oh, this is cool, you can start understanding, how things work. I went from 1 to 2. I read hands-on with machine learning. Really, so at first I read the first edition of this book, and the first edition of this book looked like this, and it was good, but TensorFlow back in the day, it was a great book. Don't get me wrong, I love this book. But TensorFlow back in the day was version 1, and that was a lot harder than the current versions of TensorFlow. I don't really know who uses TensorFlow anymore, but yeah, I feel like everyone uses PyTorch right now. But a really good book. So I read through that book, but it was hands-on, so it sort of melded these two together. Like, you worked on little exercises at the end of the chapter. Which, again, is something you can do to... I mean, a lot of the times, passive learning, they usually tell you, go do homework. Or go try this on your own or something. And that's a lot better way of learning, which I feel like is somewhere in between here. If you can't deal with the constantly feeling dumb of this, then you probably should start here. But like try to understand things from a high level. Like, just watch some videos on it. Be like, okay, I understand the concepts of linear regression, but I don't know exactly how to implement every single part of it. I don't know how to implement everything with NumPy. So go from, so if you don't, I'd say start with that. Just understand the concepts. Listen to a math class, understand the math. Don't kill yourself understanding every single detail, every single proof. Understand the overarching, okay, this is what we're trying to do. And once you get that, I'd say probably try to get to more of the interactive learning, where you build a project. So once you understand the core concepts, so ideal learning, I'd say, really leering? No. I really hate spelling. Ideal learning. Watch overview video. Like, just watch something to understand the core concepts. Don't try to take notes. Don't try to... I mean, if notes help you understand the concepts, fine, but just try and understand the main concept. Don't try to solve everything. Then I'd say build a project. And use libraries. Use sklearn. Use PyTorch. Whatever. Use anything you want. Just build a project. Get interested in it a little more. Be like, oh, this is pretty cool. Maybe build 5 projects. I don't know. Or build 1 big project. Build a project. I think DeepML comes in after this. I think at some point in your data science career or lifetime, you're going to start being like, I feel like I don't know what I'm doing. I have imposter syndrome. And also, if I want, just 2 main things. Imposter syndrome feels really bad. Just like, I don't actually know how linear regression works, or I don't know how a neural network works. So you really need to, I don't know, I lost my train of thought right there. So that's one reason I think DeepML is useful. Another reason is if you want to change anything, you actually want to build something new, you need to understand how things work in the past. Like if you want to make a new optimization technique, you need to understand how to implement Atom optimization, not just to import Atom or whatever, optimize that Atom. You really need to understand the core functionality, and if you understand that, then you'll be able to uh, implement something new, or if you, come up with a better idea. But and yeah, you're able to edit things and really get to the nitty gritty and understand what's going on. I'd say it's also useful. Once you understand how things, say DeepML, a little bias here, but I think this is. Let me do a ×3. Like you're gonna do this, or you're gonna build a few projects, at least 3. I don't know if it's 3. I don't know. These are random numbers I'm making up. Make 5, make 10, make one good one. It doesn't matter. I think DeepML is useful for, like, once you have the, oh, I want to build stuff, I really cool things, then you should start understanding, why this method is better than that method, and, just understand actually how things work, and don't just stay at scikit-learn level. I'll be like, oh, I heard this is a good method, and it might be. It's not like it might be, but you should really understand how things work. Also, why did I start this stream? I started this stream about getting things into Tinygrad. I think we got through 2 questions, and now I just started ranting about how to learn. Let's see. Okay. So DeepML. I think the main idea of another reason people should use DeepML is to prep for interviews. While, you won't be asked to implement linear regression from scratch, or you won't be asked how implement dropout from scratch. A lot of the times you'll be asked how these methods work in interviews. Like, a lot of questions will be like, oh, explain why I would use recolor accuracy. And if you just watched a video about this, or you built a project, you might not really understand how accuracy works and the different components. Or accuracy is relatively simple, but like F1 score, you might not understand what's the use case, how it's actually built. Or some people might ask like, oh, how do you regularize linear regression? These are pretty basic questions, but if you could show them like, oh, hey, I actually understand this and understand the full concepts, it looks better for you. I hope one day that I don't need to study LeetCode to get a data science job. Currently, that's the way. But hopefully one day that that changes. Hi. Any questions or thoughts about this? Yeah. Let me try to do one more Tinygrad question and convert it. Let's see, where were we? We were here. We did 1 and 2. Reshape a matrix is next. Let's see. What is the starter code? Like, why am I giving people this? Why, like... No, you gave them nothing. You have this, and you will know this is a tensor. New shape. New shape will be a tuple. And I'll output a tensor. Inputs are Tinygrad tensors. Let's just build it quickly. So I think A dot reshape. Can I do a 4x1? Okay, coolsies. Um, Cools. Solution. Dimensionality check. Oh, okay, that's useful. And test cases do we? Okay. So if it is nothing, okay, so if it's a mismatch, don't return anything. Is that in the starter code? Return tensor shape or empty tensor of mismatch, fine. Solution. Okay, if yeah, okay, fine, that works. I don't want this anymore. Need that reshape, new shape. Yeah, this seems good. Let me make sure this is good. Oh. Just delete it. That's how I know it's good. Let's see, reshape A to 4x1. Dot numpy. Okay, that works. Let's make sure test cases are done properly. Change these to tensors. Tensors. Should I add another one? I feel like it's, if you got this far, you probably got it right, to be honest. Okay, let's commit this. Make sure it's also in the meta information. Easy. Okay. Commit this. Q3. Save. What's the next one? What's the next question? I feel like I could do one more. Calculate the mean. Calculate the mean. Okay. I don't know in the mood to do this right now, to be honest. I guess after the stream, I'll add 1, 2, and 3 to the website, and people could start solving Tinygrad versions of questions. I wanted to finish a lot more this week, to be honest. I want to get up to 10 at least. But, I mean, fun way to learn the basics of Tinygrad. I also want to make a collection of, I guess, core things you should know how to do in PyTorch, like create data sets, and I forgot the actual terms, but we should to basically understand the basics of PyTorch, and we probably could do something similar with Tinygrad. Just so, like, if you solve these questions, you should understand something. Oh, back to the learning thing real quick, and then I think I'm gonna have to get going. I feel like DeepML with passive learning is very strong. So you could read something, generate a question with Deep Zero, or look up a question if we already have it, and try to solve that. And this is a really good way to reinforce the material you just read or you just watched. Sometimes, like if you read a paper, where's DeepML? We have collections and like DenseNet. If you read the paper, you could try to go in here and solve all these questions. We should have check marks next to all of these. I know someone recommended that. I'm sorry I didn't do that yet. Need to get on top of things. Okay, but thank you everyone for joining. I enjoyed this one.